We have a problem in electric potential. The problem is a charge of 8 millicoulomb is located at the origin. Calculate work done in taking a small charge minus 2 10 raised to minus 9 coulomb from point P. P has coordinates 0, 0 and 3 to a point Q 0, 4, 0 via another point R 0, 6 and 9. Okay, so first we will draw the diagram based on the question. So we have a coordinate. We have the coordinates. This is z coordinate, x, y, z. This is y coordinate. This is y and z. So we need a y and z. So we can draw the diagram like this. I just use this is y axis and this is z axis. Okay. Now this is origin. At the origin we have a charge of 8 millicoulomb. So here I mark the origin O. What's the charge here? 8 into 10 raised to minus 3 coulomb here at the origin. Now where is the point P? The point P is at 0, 0, 3 centimeter. So in Z axis. So let us choose the point P here. This is a point P. What's the position of the point 0, 0, 3 in centimeters? So we can say this distance will be equal to 3 centimeters. Now which is the other point Q? 0, 4, 0. It is in Y axis. So we can locate the point Q here. What's the coordinate? 0, 0, 4. Now what is the distance from here to here? We can mark the distance 4 centimeters from here to here. Okay. So what's the question? So we have points P and Q. We have one more point 0, 6, 9. I can mark the point R somewhere here. This is the point R. What's the coordinate of the point? It is 0, 6, 9. All in centimeters. So we have a charge at the origin. Charge has a value 8 10 raised to minus 3 coulomb. We take this charge. What is the value? Minus 2 10 raised to minus, and it is initially at P. We then take to R. So from here we take the charge to R. Then we bring to Q. We need to find the work done. So how will you find the work done? To find the work done, we have the equation work done is equal to charge into potential difference. We take from P to Q. So what is the potential difference? VQ minus VP, because which was the initial point, P was the initial point, this is the final point. We need to find the work done. So to work done, we need a potential at the initial point and potential at the final point. We need not use this position because we are doing work in the conservative, electric field is a conservative field. So in conservative field, the work done depends only on initial position and final position. So we need a VQ minus VP. Okay, so we'll substitute the values. So we have Q is equal to, what is the value Q? This is a charge which we move, minus 2 into 10 raised to minus 9. Then we have a VQ. What is VQ? Potential due to this charge at Q. What's the equation of potential? We know that 9 into 10 raised to 9. Then this charge 8 millicoulomb, 8 into 10 raised to minus 3 divided by the distance. Equation of potential is, we have equation of potential is equal to 1 by 4 pi epsilon 0 Q by R. This is Q and this is R. 4 centimeters of distance. So we have R is equal to 4 centimeter, 4 into 10 raised to minus 2. Minus, what is VP? This is a point. Potential due to this charge at the point is again similar equation, 9 10 raised to 9. Charge is the same, 8 into 10 raised to minus 3 by, what is the distance to this point? 3 centimeter. 3 into 10 raised to minus 2. Okay, so we'll simplify this. So here we have the powers 9. We can take the powers outside. Minus 2 into 10 raised to minus 9 into, I take 10 raised to 9. This 10 raised to taken outside. 10 raised to minus 3 taken outside. 10 raised to minus 2 also taken outside. So what is left inside the bracket? Here we have a 9 into 8 by 4 minus, here we have a 9 into 8 divided by 3. These are the values left. Okay. So powers are taken outside, 9 into 8 by 4, 9 into 8 by 3 left. Now we'll simplify this. What is 4 by 8? It is 2. Here we have 3. So we can simplify this. Minus 2 into, these two cancel. So this also we can cut. We have 10 raised to minus 1 left. So minus 2 into 10 raised to minus 1. 9 into 2 it is 18, minus 8 into 3 it is 24. Okay. So minus 2 into 18 minus 24, 10 raised to minus 1 into, what is 18 minus 24? It is minus 6. So 10 raised to minus 6. Here we have already a negative charge. Okay. So minus minus positive. What is the answer? 6 into 2, 12. 12 into 10 raised to minus 1. What will be the answer? It is 1.2. Work done is joule. This is the work done. Okay. So we have got. So the work done does not depend on the path. It does not. It depends only on the initial position and the final position. Okay. Now we have another problem. The next problem we have is. So we have the problem. In a hydrogen atom, I'll read the question. In a hydrogen atom, the electron and proton are bound at a distance of about 0.53 10 raised to minus 10 meter. Estimate the potential energy of the system in EV, taking zero of potential energy at infinite separation. That's the first question. Okay, we will find that one. We have hydrogen atom, we have electron and proton. So we'll mark here, this is the electron and this is a proton. Electron has a charge minus E, proton has a charge plus E. What is the separation between them? The charge is situated at 0.53 into 10 raised to minus 10 meter. This is separation. Okay, we will find the potential energy. What is the equation of potential energy? Potential energy is equal to 1 by 4 pi epsilon 0 Q1 Q2 by distance R. Q1 is equal to minus E, Q2 is equal to plus E. So what is potential energy? We will see 9 10 raised to 9 is a value of 1 by 4 pi epsilon 0. One is minus E, other one is plus E. Two charges multiplied. What is the distance? 0.53 into 10 raised to minus 10. Okay, this is the answer. We need to get the answer in EV. Okay, EV we had to convert. So to convert potential to EV, what we have to do? We have to divide charge of electron. E is a charge of electron. So 1 E cancels here itself. Okay, so what will be the answer? So minus 9 into 10 raised to 9. This 10 raised to minus 10 comes to numerator. It is 10 raised to 10 divided by, we have a E. E we need to multiply. E has a value 1.6 into 10 raised to minus 19 by, we have 0.53. Okay, how will you simplify this? 9 into 1.6, it will be 14.4 divided by 0.53 into the powers 10 plus 9, 19. Here we have minus 19, both will cancel. Okay, so this cancel with these two together. So it will be 1. So values are cancelled. What will be the value when you divide this? You will get the division. It leads to 27.16 eV. But we have a negative sign. This is the potential energy. Okay. Now we have a second question. B. This is A. B. What is the minimum work required to free the electron if the kinetic energy in the orbit is half the magnitude of potential energy? So this electron is revolving like this. If this is a nucleus, electron is revolving like this. For the revolution of the electron, it has got kinetic energy. What's the value of kinetic energy in question? Question it is told that kinetic energy is equal to half the value of potential energy in A. In A, this is a calculation A, first part. What is the potential energy? 27.16. We have to take half of that. This will be kinetic energy, half of 27.16. Okay. This will be equal to, when you take half, we'll take only plus value because kinetic energy will be positive. We'll take plus value of this, half of this potential energy. And when you take the half value, the value you are going to get will be 13 point, I can just round the value to 13.6 eV. This is the kinetic energy. Okay. So plus value kinetic energy, this is potential energy, negative value. Now we need to find the minimum work. So what will be the work? Work will be equal to negative of the total energy. We find the total energy. What is total energy? Total energy is equal to kinetic energy. This is kinetic energy. What is the potential energy? Minus 27.16. Okay. So total energy means kinetic energy plus potential. Negative of that we have to take. So what will be the value? Minus, When you subtract, you will get minus 13.6, nearly minus 13.6 eV. When you take negative of negative, you will get plus 13.6 eV. This will be the total work done. Means we need to give energy equal to the total energy. So negative we have to give. Means we have to apply the energy. If this positive energy, total energy positive, we have to give negative value to separate the electron. Okay, this is the second question. Now we have one more question today. And the question is, we have a third question. If one of the electrons of a hydrogen molecule is removed, we get H2 plus ion. So in H2 plus ion, we have 2 protons and 1 electron. So I'll say in H2, I'll draw the diagram H2 plus ion. H2 plus ion. Which are the constants H2 plus ion? We have 2 protons and 1 electron. This is the electron. And they are separated by, the protons are separated by, what's the distance? It is 1.5 into 10 raised to minus 10 meter. And each proton from electron separated by 1 into 10 raised to minus 10 meter. Here also 1 into 10 raised to minus 10 meter. Okay, what's the question? Determine the potential energy of the system. So we need to find the potential energy of this arrangement. The arrangement of 2 protons and 1 electron. That's our aim. Now we need to get the potential in EV. To get a potential in EV, how will you find potential energy? We know that total potential energy is equal to, we know the equation 1 by 4 pi epsilon 0 Q1 Q2 by R12 plus Q2 Q3 by R23 plus Q1 Q3 by R13. This is our equation. So what is R12? We can choose this one Q1, this Q2 and Q3. This distance we mark as R12. This we can mark as R13. This one we can mark as R23. Okay, we'll substitute the values. So 1 by 4 pi epsilon 0 is 9 into 10 raised to 9. We need to convert energy to electron volt. What we have to do? We have to divide 1.6 10 raised to minus 90. Now Q1, Q2. Q1 and Q2 plus E and plus E. That is E square. We'll get E square. Divided by, what is R12? This is the distance. 1.5 into 10 raised to minus 10 plus Q2, Q3. Q2, Q3 plus E minus E. That will be minus E square by, what is the distance? 1 into 10 raised to minus 10. Again we have Q1, Q3. What is Q1, Q3? These two. We have plus E into minus E. That is again minus E square. Okay. Divided by, what is the distance? 1 into 10 raised to minus 10. Okay, so we'll simplify this. So we have 9 into 10 raised to 9 by 1.6 10 raised to minus 19. We can take E square outside. E square means 1.6 10 raised to minus 19 the whole square. This is E square outside. Then 10 raised to minus 10 denominator also we can take outside. What is left inside? This is 1 by 1.5. Here minus 1 by 1. Here again minus 1 by 1. These are the values. So going to simplify. One of this will cancel. Okay, it's a square of 1.6 10 raised to minus 20. One value will cancel. What is left? 9 into 1.6 is left. 10 raised to 9 is there. 10 raised to minus 19 is there. Divided by 10 raised to minus 10. Into, what will be the value? 1 by 1.5 minus 1 minus 1 minus 2. Okay. Further we can take up. It will be 10 raised to 19. So 9 minus 19 minus 10. This cancel with these two. So it will be 14.4 when you multiply these two into, what is the value? 1 by 1.5. Okay, 1 by 1.5. 1 by 1, I'll just put like this, minus 2. When you calculate these two, that is, when you multiply these two, the answer you are going to get will be minus 19.2 eV. This will be the answer. 1 by 1.5 minus 2. Then after subtracting this, when you multiply with 14.4, that what's the answer you are going to get? It will be 19.2 minus 19.2 eV. Okay, so hope you have understood. Today we have solved three problems in electric potential. Thank you.